Okay, I've got an exam question over here. Okay, on an average, Mary scores a goal on 20% of her shots. The variable random x is number of shots Mary takes up to and including a first goal. State number one. State two conditions needed for x to have a geometry distribution. Okay, geometry distribution, two conditions that you need for geometry distribution. Okay, one, the outcome must be always, or the probability, okay, the probability, okay, the probability is always constant, okay, meaning if it's 0.2, okay, the next one is also 0.2. So not getting the shot is 0.8. So the next one must be 0.8, 0.8. You cannot have one 0.8 the next time, 0.7 or anything like that. Okay, so that's one. And then the other thing is, which I can say is the outcome doesn't influence the subsequent outcome, meaning it is independent. Okay, remember the probability is always constant, it doesn't change. And then the other one is the outcome doesn't influence the next subsequent outcome. Okay, and it is always independent. Okay, number two. Let's look at number two. Assuming these conditions are satisfied, find the probability that x equals to 3. Okay, so the probability formula, we have seen this, x equals to r, and that is equal to q to the power of r minus 1 multiplied by p. So in this case, q is getting the shot is 0.2, so not getting the shot is 0.8, and since x equals to 3, okay, on the third attempt is getting the shot, so I'll follow here. So this should be 0.8, okay, to the power of 3 minus 1 multiplied by 0.2. So the answer is 0.128. Yeah, 128. Okay, next, this is question A. What about B? Okay, B. Okay, I think I'll continue over the other side. Okay, over here, B. Okay, the question here is, assuming these conditions are set, find the probability that x is less than 10. What is less than 10? Okay, we have to understand what is less than 10. Less than 10 means the probability of x equals to 1, okay, plus x equals to 2, plus x equals to 3, and so on, all the way, since it's less than 10, all the way up to probability x equals to 9. Okay, x equals to 9. So the probability of getting hit, okay, shot on the first trial, or on the second trial, or on the third trial, or the fourth trial, all the way to the up to the 9th trial. That's what it means by x is less than 10. Okay, so you have two methods of doing it. Either you do individually, okay, all the way to the 9, okay, which is a lot, or the other method is find out what is the probability of getting greater than or equal to 10, meaning your first shot is not 1 to 9, but after that, which is 10, 11, 12, and so on. So if the first shot is only at 10 or 11 and so on, meaning the complement, okay, 1 minus, okay, 1 minus probability of x is greater than or equal to 10 will give you the probability of x is less than 10. Okay, because the moment we know what if the short is only after 10, not before that, you minus that, the complement of that, you should be able to get what is the probability of p x is less than 10. Okay, so I hope this is clear. Okay, so meaning this is you're only getting hit, okay, the shot only on the 10th shot, not before that. Okay, not before that. So if I minus this, the complement of that will be getting shot before that. Okay, so let's do that. So finding x is greater than 10, meaning no shots before that. No shots before that, meaning how many shots were there before 10? There were 9 shots. So not getting a shot before that, so p is x is greater than 10, so that should be 0.8 is the probability, which is q. Okay, not getting hit, okay, or not getting a shot, and this is to the power of 9. Okay, which is 0.1342177. So since that's not what I want, I wanted the probability of p is x is less than 10, so 1 minus 0.8 to the power of 9, and that should be 0.8658. so your answer is 0.8658. so getting a hit on either first try, p x equals to 1, x equals to 2, x equals to 3 all the way, or x equals to all the way to x equals to 9 will be 0.8658. Okay, I hope that's clear. Okay, next question. It's C. Okay, I will push it over a little bit over there at the side. Okay, question C. What do they want? Question C is, assuming these conditions are satisfied, find the probability that 9 is less than x, x is less than 9. Okay, probability of 9 is less than x, x is less than 20. Okay, this is another tricky one. So what is between this? Okay, what are the values between? Okay, let's figure that out. What are the values between 9 to 20? 9 to 20, you have 10, okay, 11, 12, 13, 14, 15, okay, 16, 17, 18, and 19. That's it. So not including 9, not including 20. Okay, remember that, not including 9, not including 20. So therefore, if I could find excuse me, okay, if I could find p is x is less than 20, which will be 1 to 19, minus p is x is less than 9, okay, which is 9, and it would be, since you have 10 over there, so can I add 9s? No, I can't have 9 there. I should have 10. Okay, I should have 10 there. Okay, I should have 10 instead. Oops. Okay, should have 10. Okay, less than 10. Then I should get the value for this. Should be p x is 9 is less than x, x is less than 20. Okay, does that make sense? Because if you find the value x is less than 20, everything from 1 to 19 minus everything x is less than 10, everything 1 to 9. So 1 to 19, okay, you have all the way, and then 1 to 10, which is less than 10, will be only up to 9. So when you minus that, you get 10, 11, 12, all the way up to 19. Okay, so I hope this makes sense. So this will be 1 all the way to, okay, to make it clear, so this will be 1 all the way to 19, okay, and this will be 1 all the way to 9. Okay, when you minus these two, okay, you get 10 all the way to 19. Okay, bear that in mind. This is inclusive. Okay, this is inclusive. So if I list down, I'll have 1 all the way to 19, and then will be 1 all the way to 9. Okay, so now let's figure this out. So the probability of getting what is x is less than 20. So to get x is less than 20, this is every value that's from all getting hit 1 to 19, inclusive of 19. So you're getting hit either 1 or 2 or 3 all the way up to 19, getting hit the 19th time, but not the 20th. So meaning if I take the complement, which is x is greater than or equal to 20, okay, greater than or equal to 20, meaning you're not getting hit, okay, from 1 to 19. Okay, so that should be 1 minus, this is to get this, okay, so to get this, x is greater than 20, meaning no hits for first 19. Let's figure that out first. No hits, okay, to 1 to 19. So no hits 1 to 19. How do I do this? No hits is 0.8. So 0.8 to the power of 19. Okay, 0.8 to the power of 19. And whereas this is, if I do the probability of x is greater than equal 10, so no hit for 0.8 to the power of 9. Okay, so now the complement of this, okay, the complement of this, okay, the complement of this will be the hit between 1 to 19. Okay, the hit for 1 to 19. So let's find that out. 1 minus the complement of that 0.8 to the power of 19. So this is the complement of this. Okay, and then this I minus with the complement of this, which would be 1 minus 0.8 to the power of 9. So meaning the complement of this is what? You are getting hit. This is not getting hit. That's why it's 0.8. Getting hit will be 1 to 19. 1 minus of not getting hit will be getting hit 1 to 9. Okay, so when I do that, okay, when you use your calculator, you will be getting 0.1198, which is same as 0.12023 SF. Okay, so remember, okay, there might be a couple of methods, but I like to understand what it means. Okay, I'm a person, I like to understand the question first. Okay, what does that mean? If I want to find between 9 to 20, they are looking at getting hit at 10. Okay, 10th trial, 11th trial, 12th trial, 13th trial, all the way to the 19th trial. So not including 9th trial, not including the 20th trial. Apart from these 2 trials, the rest of it in between, you have to find the hits. Okay, what is the probability of getting the hits? So if I find what is not getting, and then which is not getting is greater than 20, not getting. Okay, so basically what it means by x is greater than 20 means no hits for first 19. There's no hits. Your first hit only starts from 20 onwards, 20, 21. X is greater than 10. No hits between 1 to 9. Your first hit only from 10, 11 and so on. So no hits will be 0.8 to the power of 9. So complement of that should be getting hits between 1 to 9. That's what I did here. 1 minus 0.8 to the power of 9. This is getting hits between 1 all the way to 9. Okay, 1 all the way to 9 inclusive. Okay, I and C. Okay, so this is getting hits between 1 to 20 inclusive. Okay, I and C. Then you subtract these two, you get your values. Okay, for 10, 11, 12, 13 and so on all the way. Okay, try to understand this. The moment once you've understood, immediately you know next time you don't have to do so much of explanation. Okay, this is just to understand where I'm coming from. But once you've understood the question, how to do it, then you don't have to figure this out, or do so much of tedious work before you get your answer. You can immediately know. The moment I know it's between x is greater than 10, then they're talking about no hits between 1 to 9. So I can immediately go 0.8 to the power of 9. Okay, so that's how you do it. Okay, next question. Okay, let's look at the next one. So the next question will be last one. Okay, the probability that Nadine scores a goal on any shot is 0.3. Okay, this is no more binomial, is pretty much a tree diagram, I think. Okay, so probability of Nadine to score any shot is 0.3. Marie and Nadine independently take shots, turn in Marie taking the first shot. Okay, the winner is the first one to score 2 goals. The winner is the first one to score 2 goals. Okay, let's look at that. Okay, winner is first one to score 2 goals. So before that, let's list down what are the values over here. So you have, let's say I have Nadine. Okay, for Nadine to score is 0.3. Okay, and not to score is 0.7, whereas Marie to score is 0.2 and not to score is 0.8. Okay, 2 values. Okay, now who's the first person? Excuse me. Okay, who's the first person? Marie wins on a second shot. Marie wins on a second shot. So Marie wins on a second shot. So Marie, who's starting? Marie is going first. So I should start with Marie. Okay, and then Nadine, and then Marie. Okay, so so if Marie is going first, so that is she's winning for the first time, and then Nadine is not winning. Okay, Nadine is Nadine could win, isn't it? Okay, Marie, Nadine, and then Marie again. Okay, so you times this. So Marie to win 0.2, Marie Nadine not to win, to win is 0.3, Marie to win again is 0.2. So that should be 3 over 250. Okay, and then the next bet is again Marie, Nadine, Marine. So Marine chance or this is or either one of it. So Marine can go first. So Marie is, because Marie is already said that Marie is shooting first, so we have to start with Marie, so 0.2, and then Nadine might not be scoring, okay, or might not be shooting, so it's 0.7, right? And then she has to shoot again. So from there we have 7 over 250. You add these two, you get 10 over 250, which is 0.04. Okay, next. Nadine wins on her second shot. Nadine wins on her second shot. Okay, so how do I do this? Nadine wins on her second shot. So let's list that down. M and M. Okay, Marie is going first, so there should be another Nadine then. Okay, so the probability that can happen. So Marie is going first. And since Nadine is winning on the second shot, so she has to win on the first shot, and then Marie might miss it, okay, and then Nadine could win, okay, because she's winning on the second shot, so she must win 2 shots, or Marie could be losing first shot and Nadine is winning at the her first shot, followed by Marie, which is winning, and then Nadine is winning. Okay, so that could happen. Okay, and then there's one more. Okay, Marie could lose, Nadine could win, and Marie could lose again, isn't it? Yeah, and then Nadine could win again. Okay, so these are the 3 possibilities. So plus and plus. Since you have 3 possibilities, you have to consider all 3 possibilities. So the answer is 9 over 6 to 5 over here, and this is 9 over 6 to 5, and the last one is 36 over 6 to 5, and when you add all 3, you get 54 over 625, and that's your final answer. Okay, I hope this makes sense. Thank you.